Alright, for our final video on direction angles, we're going to talk about one that's in quadrant 4, and we're going to be given an initial point and a terminal point. So we haven't seen one like this in these videos just yet. If you watched the original vectors video, you would have seen this sort of layout here, and it wouldn't have been a big deal. The idea for these is that they give you 2 points, P and Q, and I know that they're positioned where they are here because I know that 2, 6 would have to be to the left of 5, -3, because 2 is smaller than 5, but that it should be above it because 6 is bigger than -3. So I take a look at it. I see that my vector would point in this direction because it says from P to Q. So this is P and this was Q. This is how I know that this is a fourth quadrant vector, because it's pointing down and to the right. And I know that my angle theta would have to be this massive angle. I say massive simply because it ends up in the fourth quadrant. It's bigger than 270 degrees. Of course, it'll be less than 360 for our purposes. At this point, they didn't give us our x or our y component. Hopefully you could tell that it would be a positive x and a negative y. But I'm moving from 2 to 5 horizontally, so this is a distance of +3, and I'm dropping from 6 down to -3, which is a total distance of 9. And that's the hardest part about a problem like this, is that people will often slip up with the double negative there. They might say 6 to 3 is 3. They might not pay attention to this being -3, or they'll accidentally put a +9 because they'll just think from -3 up to 6. And so those little tiny mistakes can add up, and that will cripple the problem. You will not get it correct if you have the wrong value there, most likely. However, at that point, everything else is the same as before. Our reference angle is going to be inverse tangent of our y component, which is -9, over our x component, which was +3. We'll go to the calculator, we'll verify that's in degree mode, and then we'll go in and say, well look, second tangent or inverse tangent of -9 divided by 3 gives me -72 degrees. Now I've been rounding to whole numbers. Just be mindful that sometimes people prefer something else. -72 degrees. Well, if we add 180 to that, let's just test that out. That's what we did in our last couple of videos. If I add 180 to that, I end up at 108 degrees, which is in the second quadrant, which is not far enough. So I've only gone halfway around the circle. This was originally in the fourth quadrant, but it's negative. So really, we're looking for a coterminal angle. We want to get back to where we were, so we need to add the total 360, which in this case, I just add another 180. And we're going to see that when I add that 360 degrees, we end up with a theta value equal to 288 degrees. That would be our angle, our direction angle, for our vector PQ.